section 3.6, we're going to be solving polynomial and rational inequalities. So first of all, what I will talk about in this section is what is the basic definition of a polynomial inequality to begin with. Okay, so this definition that I'm going to show you next is also going to apply to the rational inequalities. So let's say we have a polynomial function. So I'm just going to say a smooth continuous curve that goes somewhat like this, for example. Okay. So this function, I'm going to call it f of x. Now, something that we have been talking about in the previous sections, 3.2, 3.3, 3.4, we talked about the zeros of the polynomial function. So these are the zeros, which we call it zeros because those are the values for which f of x is equal to 0. So that's why we call them zeros. Now, when we talked about an inequality, there are two possible inequalities. One of them is f of x is greater than 0, and the other inequality could be f of x is less than 0. When we say f of x is greater than 0, that would mean all of the values of x for which the value of y is positive. So in other words, all the values of x for which the function is above the x-axis. So that's what this concept is going to be meaning, above the x-axis. Okay, so you can see that there's two little pieces on the graph for which this function is above the x-axis, from here to here, and also from this point to infinity, because it is above the x-axis anywhere afterwards, right? Likewise, when I say that a function is less than 0, that consists of the values that lie below the x-axis, the values of x for which any given function is below the x-axis, and that would mean on this little section and also this little section. So anywhere from negative infinity up to this point, the graph is below the x-axis, and anywhere between this point and this point, the graph is also below the x-axis, meaning less than 0. Okay, so when I have a polynomial function, keep this in mind, and the polynomial is greater than 0 means I'm looking for any value, all the values of x for where the function is above the x-axis, and when I have a function less than 0 means I'm looking for all the values of x for which the function is below the x-axis. So we're going to start now. One of the things that we need, of course, as you can see, that is very crucial in order for me to find that, is the zeros. The zeros are my basically are my key points or we call them boundary points that we're going to use in order for us to find our intervals for the solutions of these inequalities. So I'm going to guide you through the process. We're going to start by solving this inequality first. So this inequality states, solve the polynomial inequality and graph the solution set on a real number line. 4 minus x to the second power times x minus 9/2 is less than 0. So if I were to graph this function, we are basically looking for all the values of x for which this function is below the x-axis. That's what the less than 0 basically means. Okay, I can graph it in the graphing calculator and see all the little intervals from where to where is it below the x-axis. That's what I'm basically looking for. Now, on the first thing that we need to do on the polynomial inequalities is that number one, we have to find our boundary points. Our boundary points are the zeros of the equation. So basically, to find the zeros, we want to find the values of x for which this is equal to 0. Okay? So we need the procedure that we need to use to find the zeros, just as before, is that we need to factor and then set each factor equal to 0. But in this case, as we can see, this polynomial is already in factor form. So all we gotta do is set the factors equals to 0 and solve for x because it's already factored. So this one is gonna give me x is equal to 4, and this one is gonna give me x is equals to 9/2. Those are the zeros. Now, those are the solutions for the equation 4 minus x squared times x minus 9/2 equals to 0. But I want to find the solutions for the inequality for which this is less than 0. So, to find the solutions to the original inequality, the last step in the process is going to be this. You're going to put those zeros in a number line. Okay, so we have 4 and 9/2. So 4 goes first, and then you're going to divide it with a boundary line right here. And then 9/2 is 4.5. So I'm going to put the 4.5, which is 9/2, a little after, and I'm going to divide here with a boundary line. So what you need to do is that you need to pick test points. This is the next step in the process. What is a test point? A number that I'm going to substitute to test each of those intervals to see which ones are true and which ones are false. That's what the test points are going to be for. Now, we need to pick a test point on each interval. Now, there's an interval right here from -infinity to 4. That is one interval. Between 4 and 9/2, that's another interval. And from 9/2 to positive infinity, that's another interval. So we need to pick a number that is on the left side on this interval. You can pick 3, 2, or 1, or 0, or -1, or -2, anything as long as it is less than 4. I'm going to pick the easiest one for me, which is 0. Right here in the middle, between 4 and 4.5, so we have very limited choices. I'm going to use 4.1. Right here on the right side of 4.5, we can use 5, or 6, or 7, or 8, or 9, or 10. I'm just going to use the number 5. So what you need to do is, you need to substitute those values into the original inequality to find if they are solutions of this. Okay? So I'm going to substitute each one. So we're going to start with the first one. So it's 4 minus x, which is 0 right here. This is my x, squared, times x, which is going to be 0, minus 9/2. So you know what? Instead of the 9/2, I'm going to use a 4.5 for that. Okay? So 0 minus 4.5 is less than 0. Let's test it out. 4 minus 0, it's going to be 4. If I square it, that's a 16. 0 minus 4.5 is negative 4.5. So if I multiply times 16, 64, then an 8 is 72, negative 72. Now the question is that less than 0, true or false? That is true. Let me tell you what this means. Since 0 makes this inequality a true statement, when it makes it true, that means that it is a solution. Since 0 is a solution, that means that if I substitute any number from this interval, from -infinity to 4, any number in this interval is going to be a solution of that inequality. Okay? Every value here is going to be true. So on my solution set, I'm going to say that anything from, I'm going to put solution right here. I'm going to say that anything from -infinity all the way to 4 is a solution so far. Okay? Now, let's talk about the one in the middle. So I'm going to substitute 4.1 in the x. So it's 4 minus x. And in this case, x is going to be 4.1 squared times x, which is 4.1 minus 4.5, has to be less than 0. So 4 minus 4.1 is negative 0.1. If I square it, it's going to be 0.01. And then 4.1 minus 4.5 is going to be negative 0.4. Right? So if I multiply negative 0.4 times 0.01, it's going to be negative 0.004. So the question is that less than 0, true or false? that is going to be true also. So what does that mean? That means that any number from 4 to 4.5 is also going to be a solution, because it's going to make that original inequality true. So we're going to say union. So anything from negative infinity to 4, or anything from 4 to 9/2, which is 4.5, is a solution. Now we're going to test the last interval. So we're going to replace the 5 into the x. So it's 4 minus x, which is 5 squared, parentheses x, which is 5 minus 4.5, is less than 0. 4 minus 5 is going to be negative 1. And if I square it, it's going to be a positive 1. Now 5 minus 4.5 is going to be 0.5. 1 times 0.5 is going to be 0.5. Is that less than 0? That is going to be a false statement. Since this last one is false, that means that any number from 9/2 to infinity is not a solution, because any number in this interval is going to make that inequality false. So my solution is any number from negative infinity to 4, or any number from 4 to 9/2. It is a solution. Now, let me show you. If we were to graph it, what were we looking for? Less than 0 means we're looking for all of the values of x for which the function lies below the x-axis. So we go to the y equals, and we put this in the graph, 4 minus x squared, and in another parenthesis, x minus 9/2, and we go to the graph. You will see that the graph is below the x-axis, anywhere from negative, well, let me zoom in that little section for you so you can see it more closely. I'm going to zoom in this little section, so you can see just that little section here. Let's see if we can see it better. Anywhere from negative infinity to negative 4, the graph is below the x-axis, but you cannot see it very carefully here, but from negative 4, from negative infinity to 4 is below the x-axis, but also from 4 to 4.5 right here, it is also below the x-axis, but we can barely see it. And after 4.5, the graph is above the x-axis. So we were looking for just the pieces below the x-axis, which is from negative infinity to 4, or right here from 4 to 4.5. Okay? Now, let's go ahead and take a look to the next inequality. Now we're going to be finding the solutions to this one. Solve the polynomial inequality and graph the solution set on a real number line. So the first thing we gotta do is that we have to find the zeros. To find the zeros, we need to make that inequality into an equal sign. Oh, but it is not a 0, it is a negative 3. So you know what you're gonna do first. In order for me to be able to factor this, first thing we need to do is we need to make it equal to 0 by moving the 3 over to the other side. So it's gonna give us a 4x to the second power plus 7x plus 3 equals to 0. Then we're going to create the factors. We're going to have an x on each factor as usual, and on this one we need to get the GCF as usual. So the GCF right here between 4, 7 and 3, it is a 1, right? So we're going to multiply a times c to factor the trinomial. We're going to use the AC method. That's going to give us a 12. So we need two numbers that when multiplied they give me 12, and when added they give me a 7. That would be a 4 and a 3, right? And it would be positive 4 and positive 3. Then to finish these factors, we have a 4 as the value of a, so what we need to do is divide them both by 4. So the first factor, 4 divided by 4, gives me x plus 1. And the second factor, since I cannot divide by 4, the 4 goes in front of the x, so that would be a 4x plus 3. Then we're going to find the zeros of this. So the zeros will be x equals negative 1, set them equal to 0 and solve for x, and x equals to negative 3/4. So those are my boundary points. So now we're going to draw the number line, and we're going to select the test points right here that we're going to test. So we're going to get the test. First of all, let's put the boundary points, which is negative 1 and negative 3/4. So first is negative 1. So I'm going to put the negative 1. And I'm going to create a boundary line right here. And then we have the negative 3/4. And I'm going to create a boundary line. Okay, so we need to take the test points in this, the numbers that we're going to test. So what could be at the test point that we can use on the left side? Well, anything as long as it is less than negative 1. So I'm going to use negative 2. It could be also negative 3 or negative 4 or negative 5. Anything as long as it's less than negative 1. Now, right here on this one, anything between negative 1 and negative 3/4. Keep in mind that negative 3/4 is negative 0.75. So we have negative 0.8 or negative 0.9 or negative 0.95, negative 0.85, or so on and so on. So I'm just going to use negative 0.8. Anything after negative 0.75, I can use 0 or 1 or 2 or 3 or 4. So I'm just going to pick the 0. So we need to substitute those into the original inequality, which is this. And we're going to determine which one of those intervals are true. That's what we're looking for. So, first one, 4 times x, x is negative 2, squared, plus 7 times x, which is negative 2, must be less than negative 3. So, negative 2 squared, it's going to be a 4. So 7 times negative 2, it's going to be negative 14. 4 times 4 is going to be 16 minus 14. That is going to give us a 2. Is that less than negative 3? True or false? That is going to be a false statement. What does it mean? That means that any number from negative infinity to 1, negative 1, is not a solution, because it's going to make that original inequality false. Now, the one in the middle, 4 times x, which is negative, I'm just going to put negative 0.8 squared, plus 7 times x, which is negative 0.8, is less than negative 3. Now, negative 0.8 times negative 0.8 is 0.64. Then 0.64 times 4 is 2.56. Yeah, 2.56. Then 7 times negative 0.8, it's going to be negative 5.6. Now we're going to combine them. 2.56 minus 5.6 is negative 3.04. The question is that less than negative 3, true or false? That is true. Since this value, negative 0.8, makes that inequality true, what does that mean? That means that any value between negative infinity, between negative 1 and negative 3/4, it is going to be a solution, because it's going to make that inequality true. So far in my solution set, we have that anything between negative 1 and negative 3/4 is a solution. Let's test out the last interval. So now we're going to test the 0 on the right side. So it's 4 times 0 squared plus 7 times 0 must be less than negative 3. Now 0 squared is going to be 0. Times 4, it's going to be 0. Plus 7 times 0 is going to be 0, so that gives us a 0. Is that less than negative 3? No, that is going to be a false statement. What does that mean? That any number greater than negative 3/4, or any number from negative 3/4 to infinity, is also not a solution, because it's going to make that original inequality a false statement. So my only solution for this system, for this inequality, is going to be any number from negative 1 all the way to negative 3/4 is going to make it true. Next inequality. Now we're going to be solving this one. Or, you know what, let's solve, yeah, that's okay. Let's solve this inequality here. Solve the polynomial inequality and graph the solution set on a real number line. So, first of all, we're going to find the zeros of this inequality again. So we got 2x squared minus 5x. We're going to change it to an equal sign, and then it's a 0. Now, it is already set to 0 on this side. So all we got to do is we're going to factor this. So remember, to factor, we start with finding the GCF. What is the GCF of these two? We can factor an x from both of them. Right? That's all we can factor. So both of them have x in common. So we're going to take out an x, so we're going to divide an x from both of them. So if we do that, we're going to be left with 2x minus a 5. Then we're going to set m equal to 0, so we get x is equal to 0 right here. And if we solve for x on this one, x is equal to 5/2. Okay? Because remember that you have to set it equal to 0 and then solve for x. So if you put it like this, 2x minus 5 equals 0, you're going to add the 5 over to the other side, which gives you 2x equals 5. And then you're going to divide both sides by 2, which gives you x equals to 5/2. Okay? So my two zeros are 0 and 5/2. So now we're going to use the number line to test my test points. That's the next part of the procedure. So we're going to label the zeros there, which is the 0 and 5/2. I'm going to put my first boundary point at 0. So we cannot use it as a test point any longer because it is a boundary point. Then the next one is 5/2. And I'm going to put a boundary line at 5/2. So, let's pick the test point. On the left side of 0, we can test -1 or -2, -3, -4, -5, anything that as long as it's negative, right? So I'm going to pick -1. Between 0 and 5/2, I can pick 1 or 2, or any decimal, that is not 1 or 2. After 5/2, I can pick a 3 or a 4 or 5 or 6 or 7 or anything higher. So I'm going to pick a 3. So we need to substitute them back into the original inequality. So that's where we need to put them. And we need to determine which ones make it true. So it's going to be 2 times x, which is -1 squared, minus 5 times x, which is -1, is greater than 0. So that's 2 times -1 squared is 1. -5 times -1 is +5. So we get 2 plus 5, which is going to be a 7. Is this greater than 0, true or false? That is going to be a true statement. So what does that mean? That means that any number from -infinity to 0, it's going to be true because it's going to be a solution because it's going to make that original inequality a true statement. So on my solution set, I already know that anything from -infinity to 0, it's a solution. Now, next one. 2 times x, which is 1 squared. Then minus 5 times x, which is 1, is greater than 0. So we're going to get 1 squared is going to be 1. Minus 5 times 1 is going to be -5. 2 times 1 is 2. Minus 5, that's going to give us a -3. Is that greater than 0? True or false? That is going to be a false statement. What does that mean? That means that anything between 0 and 5/2 is not a solution because it's going to make the original inequality false. Last but not least, 2 times x, which is 3 squared, minus 5 times x, which is 3, is greater than 0. So it's going to be 2 times 9 minus 15, and that's going to be 18 minus 50, which is going to give us a 3. Is that greater than 0? that is also going to be true. So what does that mean? That anything from 5/2 to positive infinity is going to be a solution because it's going to make the original inequality a true statement. So my solution is anything from negative infinity to 0 right here, or anything from 5/2 to positive infinity. And that is my solution. Next inequality. So now we're going to be solving the rational inequalities. So there's two of them that we're going to do. We're going to start with this one, and then we're going to do one more after this. Solve the rational inequality and graph the solution set on a real number line. Express the solution set in interval notation. So, for the rational inequality, to find the 0, we're going to do it kind of the same way, but in other cases it could be different. Okay? Now, whenever we have a 0 on the other side of the equation, just like I showed you in section 3.5, all you can do is find the zeros of the numerator. That's how you find the zeros in that case. But what if the other side of the equation is not a 0? Then you have to do it in the following way. I'm just going to show you the way I instructed it in section 3.5. So to find the 0, I need to first of all get rid of this fraction by multiplying the denominator x plus 9 on both sides of the equation. So x plus 9 cancels out, simplifies, divides out on this side. It simplifies. So that gives me x plus 2 equals, if I distribute that 0 times x and 0 times 9, we are still going to get a 0. That's what I'm telling you. If you have a 0 on the other side of the rational equation, then to find the zeros, all we have to do is find the zeros of the numerator, basically. Okay? Because you see that the denominator just doesn't affect it. It still stays as a 0. But what if this number on the right side is not a 0? Then that is a different story. Okay? So, we subtract 2 from both sides, and that gives us x is equal to -2. Okay? Now, for the rational inequalities, there's one more part to the question. You also need to find the zeros of the denominator, which is my excluded values. If you remember, that's what we call them. The zeros of the denominator, the excluded values, the wholes, the vertical asymptotes of the actual function. So we need to find the zeros that make the values that make the denominator 0, which in this case, if we solve it, is x equals -9. Okay? So we're going to do the exact same thing, which is we're going to draw the number line and we're going to choose test points. Okay? Now we're going to put, of course, the -9 and the -2 as the boundary points. So I'm going to put first -9, and I'm going to put a boundary line right here, and then we have -2, and I'm going to put a boundary line right here. So we have to pick the test points next. What could be my test points in this one? So anything on this side, we can use -10 or -11 or -12, so I'm just going to use -10 right away. In the middle between -2 and -9, you can use -8, -7, -6, -5, -4, -3. I'm just going to use -3. And on this side, you can use -1, 0, 1, 2, 3, 4, 5. So I'm just going to pick the 0. Okay. We need to replace them back into the original inequality. So we have to go back to this one and replace them in there and see which intervals make that inequality true. So x, which is -10 plus 2, over x, which is -10 plus 9, is greater than 0. So -10 plus 2 is going to be -8, divided by -10 plus 9 is -1. -8 divided by -1 is 8. Question is that greater than 0? That is going to be a true statement. So what does that mean? That anything from negative infinity to negative 9 is going to be a solution because it's going to make the inequality true. So on my solution, I'm going to put anything from negative infinity all the way to negative 9 is a solution. Now, the middle interval, negative 3 is my x. So x, which is negative 3 plus 2, over x, which is negative 3 plus 9, must be greater than 0. Negative 3 plus 2 is negative 1, over negative 3 plus 9 is 6. Negative 1 over 6 is negative 1/6. Is negative 1/6 bigger than 0? That is going to be false. What does that mean here? That anything between negative 9 and negative 2 is not a solution because it's going to make the original inequality false. And last, x, which is 0, plus 2, divided by x, which is 0, plus 9, must be greater than 0. So we're going to get 2 9s. Is 2 9s greater than 0? That is going to be true. Since that one makes it true, that means that any number from negative 2 to infinity is also a solution because it's going to make the original inequality true. So we're going to say that the solution is anything from negative infinity to negative 9, or anything from negative 2 all the way to positive infinity. This is the solution for that inequality. Last but not least, we're going to cover the toughest one on the rational inequalities, which is going to be this one. Solve the rational inequality and graph the solution set on a real number line. Express the solution in interval notation. 11x plus 2 over 4x minus 1 is less than or equal to 4. So, on this one, to find the zeros, what we have to do is this. Okay, so we have to basically do it the same way. You see that the other side of the equation is not a 0 anymore. So it is a 4. So we're going to do it the right way. So first thing, I need to get rid of the denominator to find the zeros, which is I'm going to get rid of it by multiplying that 4x minus 1 on both sides of the equation. Multiply the 4x minus 1, so it cancels out on this side. And that cancels, it divides out, or it simplifies, or it reduces. So we are left with 11x plus 2 equals, then right here we need to distribute the 4, and that's going to give us a 16x minus a 4. What we need to do next is we need to solve for x. So I'm going to subtract the 11x from the other 16x right here. So it's going to give us a 2 equals to 5x minus 4. Then I'm going to add the 4 to the other side. So it's going to be 6 equals to 5x. And then we divide it by 5 right here. So we're going to get that x is equal to 6/5. That is my 0. Okay? 6/5. So now what we need to do is we need to find the 0 of the denominator. Zeros of denominator. Let's do that. So we need to find the values that make the denominator equal to 0. So we're going to add the 1 to the other side. So we're going to get 4x equals 1. Then we're going to divide both sides by 4. So it's going to give us x is equal to 1/4. So those are my two zeros. My 0 of the numerator and my zeros of the denominator. So now we're going to use put them on the as boundary points, the two values that we got, 6/5 and 1/4. Those are my boundary points. So I'm going to start with the 1/4, and we're going to create a boundary line at 1/4. Then we got 6/5, and we're going to put a boundary line at 6/5. Okay. So right here we want to find the solutions for this inequality. So we want to select some test points, and we are going to test them into this original inequality. So what could be my test point? So on this side we could use 0 or -1 or -2 or -3 and so on. In the middle between 1/4 and 6/5. 1/4 is 0.25, 6/5 is 1.2, so we can use the number 1 right here. On this side, after 1.2, we could use 2 or 3 or 4 or 5 as a test point. So I'm going to use the number 2. So we're going to substitute them and see if which ones are true. 11 times x, which is 0, plus 2, over 4 times x, which is 0, minus 1, must be less than or equal to 4. So 11 times 0 is going to be 0, plus 2, it's going to be a 2, over 4 times 0, which is 0, minus 1, is -1. So you're going to get 2 divided by -1, which is going to be -2. Is that less than or equal to 4? True or false? That is true. So what does this mean? That any number from -infinity to 1/4 is going to be a solution because it makes the original inequality true. So far the solution is anything from -infinity to 1/4. Now, keep in mind one right here is that this original inequality has an equal to 4. Okay? Just because it has an equal sign, that doesn't automatically mean that this 1/4 is going to have a bracket. Okay? You need to be careful when it comes to the rational, because you need to keep in mind that where does that 1/4 comes from? It comes from the denominator. And what happens if we get a 0 on the denominator? It makes the function undefined. So anything that makes the denominator 0, even though you have an equal sign on the inequality, it will never be included as a solution. So it will always carry a bracket, parentheses. Because the 1/4, it is a 0 of the denominator, meaning that it makes the denominator 0. It is a vertical asymptote. It cannot be included. Okay? So let's find the rest of them. Now I'm going to substitute the 1. So it's 11 times 1 plus 2 divided by x. 4 times x, which is 4 times 1 minus 1, is less than or equal to 4. So 11 times 1 is 11 plus 2 is a 13. 4 times 1 is 4 minus 1 is a 3. So 13 divided by 3, that is going to be 4.3. Is that less than 4 true or false? That is a false statement. So what does this tell us? That any number between between 1/4 and 6/5 is not a solution of the original inequality because it's going to make it false. Last but not least, we're going to substitute the test point on the right side. So it's 11 times x, which is 2, plus 2, over 4 times x, which is 2, minus 1, must be less than or equal to 4. So that's a 22 plus 2, that's a 24. That's an 8 minus 1, that's a 7. So we get 24 divided by 7, and 24 divided by 7, it's about 3.4 approximately. Is that less than or equal to 4? True or false? That is also true. Since that one makes it true, that means that any number from 6/5 to infinity, it is also a solution because it is going to make the original inequality true. And right here, the 6/5 is going to be included with the square bracket because 6/5 makes this fraction equal to 4. And right here, the equal sign is being included. So 6/5 is going to be included as part of the solution. Okay. And of course, the union symbol. So this is the solution for this inequality. Okay. So this problem concludes section 3.6, which is polynomial and rational inequalities.